Hello, everyone. Hey, Patrick, I think we are live.
I think we are live too. How are you doing, Alex?
Yeah, very well. It's, well, not the best of the weather today, but looks amazing to see how many people we have today in the stream. So, you know what? I don't care about the weather.
We're all inside, and that's the best thing about being a nerd, is most of what we need to do is inside a room with air conditioning.
Oh, yeah, makes sense. What's the temperature at your side of the planet?
I'll make everyone angry. It's beautiful, sunny, and it's about 20 degrees Celsius right now.
Okay, a special thank you for Celsius, because I still don't understand Fahrenheit.
I never got it either. I don't know why Fahrenheit even exists. Like, why does water freeze at 32 degrees and boils at 212? I just like water freezes at 0, it boils at 100. Easy.
Yeah, really,
Easy.
really.
Yeah.
Okay.
All right. So now that we've chosen that topic, let's go there.
Yeah, so take a look, everyone at the screen. What you see here is kind of stadium and people playing tennis, but I don't care about the tennis today, because what we have is the amount of people you are seeing at your screen is the approximate amount of registrations for this course, because everyone wants to be successful with cloud native applications. So we have over 10,000.
Yeah, and I actually recognize some of those people if I look in the stands. I've seen some of you at meetups and at ApacheCon and Accelerate, Cassandra Summit. So it's great to see some familiar faces in that crowd.
Yeah, definitely.
Wait a minute, when did we take that picture?
Link above. That's just visualizing crowd sizes. As we got some people, like, we really want to understand. Before, we did a lot of offline events where you travel to a city and gather people together, and like there is like a meetup size events, like 50 people, sometimes up to 100, but usually around like 50 or something like that. And we were happy because there is so much of a live communication. As soon as we went live, numbers just start to explode. And now for this workshop series, we have more than 10,000. I still cannot believe in it.
Well, I mean, this is how it goes, right? Everyone's sheltering in place, which is good. Stay home, stay safe, and it doesn't mean you can't stop learning, right? And there's lots of ways to do it. Of course, we're live on YouTube and on Twitch. We have our Discord. As a matter of fact, love the Discord. Already looking over there, and people are talking about Fahrenheit and Celsius. Yeah. All right, that's an engaged audience. But I mean, this is easy enough to do, and it's not only that, you get you don't get a diminished experience, and that's what we're trying to do. You're going to learn about Cassandra, you're going to learn about Kubernetes, you're going to learn about microservices, and you can do all this online. I watch a lot of YouTube, and I watch a lot of Coursera, so yeah, why not?
Yep. Whatever, all this pandemic was such a big surprise, it's still a great time to take time for yourself and learn something new. Okay. So,
what are we learning today? Is the question.
Well, you know what? Yes, we learn a lot of great things today, but what I want to start is from whom we're learning today. And we have a really incredible team today. We have just a great Data Stacks Developer Advocacy Special Unit doing this workshop series for you. And there is a very great team. I'm so happy to work in this team of very many people. Today on the screen for you, Patrick McFadden and me, Alex VOLOCHNEV, developer advocate at DataStax, but also we wouldn't be so strong without the crew covering us in Discord and at YouTube channel and all the people developing Discord. So that's the most important, with whom you are working and who is preparing content for you. And now what we are going to learn today. Well, you asked a really good question. We have an incredible set of things to discuss. This week is the second week of this workshop series. I hope you did attend the first week. If you didn't, no worries, everything is recorded and available for you, including exercises, all the steps, everything except of the quiz. Well, sorry, sometimes you have to be on time, but the main thing, the content is available. And last week we were talking about the very fundamentals of the Cassandra. What is it, why it's great, how it works, and so on. And today, that's actually a very special moment for me because that's one of my favorite topics, data modeling for Apache Cassandra, or I prefer to call it creating an efficient data model for the highly loaded applications. You may use the best database in the world. Well, for most of the workloads, Cassandra is the best one. But if your data model is bad, you can ruin everything what Cassandra gives you, like you have highest efficiency, you may ruin it with a data model done wrong. You have the highest availability, you can ruin it with the data model done wrong. So we talk how to be successful with Cassandra. That's the main topic for today, Patrick.
Oh, that's a good topic. And that's the one I love too. Your application starts with a great data model. And if you're using something like Astra, it's pretty much all you're going to work on because you don't have to work on the actual database anymore. You just click a button and get yourself a new database and run. And that's actually what we're using today too, Alex, is we're using Astra like we did last week. So if you didn't catch last week, that's fine. You can go back and watch the video. We record everything. Everything's on YouTube, of course, like everything else in the world. But you can catch up from last week. If you're watching this late, let's say you're watching this version recorded, go ahead and catch up. We have 7 more weeks of content coming, or 6 more weeks of content coming, and it's all really good. And we're walking you up from the beginning to actual deployment of building a cloud-native application. And this is an amazing skill. And by the way, you get a certification at the end as well.
Yep. So we teach you for free, and you have a chance to get your certificate for free. This usually costs like around $400, I believe. Okay. So, and how does it work? Every week, you have to choose which session is better for you from the time zone point of view. So one is running right now, and one we will do again Thursday, which will be for me Thursday morning. So choose one what matches your time zone. We have basically covered all the globe, which is great. And during the workshop, you have to use some tools, and you may need some places to visit. So obvious place to be youtube.com datastacksdevs. I hope, where are you exactly right now? Or maybe you are watching us at our backup channel at Twitch. We also streaming at Twitch, but the main channel is the YouTube. Then the main place to ask questions is our Discord server. So bit.ly/Cassandra-workshop. And that's the best place to ask questions. Can you ask questions on YouTube? Well, yes, you can, but as soon as the workshop is over, your questions will be gone, and Discord is much better place with much better coverage and ability to always discuss the things. To run the quiz, we will use mentee, and it's going to happen very soon for the first warm-up. Then to do all the exercises, we use Astra. Astra is a great thing. DataStax Astra, as Patrick said, Cassandra is a service. The only thing you have to worry about is your data model. We are taking care today, so you don't have to worry about anything anymore. And DataStax takes care of the management of the cluster. And trust me, there is a lot of work to do. To handle the materials, everything at our github.com/datastax-academy/Cassandra Workshop series. And I hope you have been there already. And if not, you should. And starting next week free with Cedric Lundan, you will do a lot of coding. So be prepared to do a lot of coding work with Gitbot. Still, you don't have to install anything. Everything is in the cloud, as we do. After the workshop, you have to take care of the homeworks, and that's an important step. Don't take your homeworks or home assignments like not too serious. They are serious if you want to not only to just get the certificate, but really be efficient and successful. With Cassandra, you must do your homework. Take it serious. At the homework, you may need our forum and place to communicate and discuss questions with many of the people, community.datastacks.com. You will need to get some trainings at the academy.datastacks.com. To chat, you can use Discord, which is as shown on the screen, and you will have to validate your presence at the week 2 to get your voucher. With a Google form, we are sending to the chat in the end of this workshop. And after that, relax, you are already great. Today, let's get to today's topic. First thing we have to discuss some things about the Cassandra, which may be not typical for another databases, so you may need to learn something like key spaces, partitions, and so on. Second part and the main part is the art of the data modeling. How do you develop a good data model? When we discuss data types, basic data types, advanced data types, and then what comes next. And before we start, we are speaking all the time, Patrick. Let's people answer our questions like we are answering questions all the time. Let's go mentee, and mentee code for today 894947. I repeat, 894947.
And remember, this is a competition, so we're not the first one. We're going to start out with just a quick question to warm everybody up, make sure you're connected. But this will be a competition at some point. We will be watching who's doing what.
Yeah. So fast people and people answering questions in the right way, we will get some stuff. Okay.
And it will be about what we're learning today. And so it'll be relevant. And that's what we're going to try to keep you engaged here. But yeah, follow along. This could be a fun contest.
Exactly. So we have, I see already more than 100 people at Mentee. Don't be lazy, join Mentee now. We have a lot of guests today. And join it to be ready for the competition. But now just simple questions to warm up. We give you 20 more seconds, only 20 seconds, and we start.
All right. Well, this is when it gets real. We actually have interaction other than chat. Although I'm looking in the, if you're doing the YouTube chat, that's fine. We do have people there. But really, we prefer you go over to Discord. Discord makes it a lot easier. If you have a one-on-one question, you can split people off into a different room. It makes it a lot more interesting for, like, if you have something more in depth to talk about. We have a lot of folks in there. So Discord is a really good place for you to be. And Discord stays online. We have right now, currently we have 600 people active in the room. I've seen it a lot higher, but I would also encourage you to help each other. If you're not new to the community, this is a great place to participate, help out each other out. If you see a question in there that you know the answer to, feel free. I mean, answer that question.
Yep. I see people are asking what's the deadline for the homework. And you know what? We really want it to be a self-paced course. So we don't know your situation, how busy you are, and what's going on next to you. So take your time. We don't close assignments except so forms are available. If you can do it on time during the same week, it's great. But if you cannot do it for any reason, we don't want to block you, seriously. So take your time and pass the homework when you will be ready, but don't wait for too long, okay? Okay, so I see most of the people logged in, so let's start the questions. Okay, Mentee, get back to me. That's not the first time. You see, they're scared of our numbers. Every time we have more than 100 or 2, Mentee starts to stuck.
I feel like David had this problem before too. We had to
Yeah,
solve it or
not only
something.
David.
Yeah, you
Okay.
have to do a hard
Yeah,
refresh.
I think so. I will do a hard refresh for this one.
Yep. See, this is why we have friends that sitting behind the scenes and Slack us like, hey, do a hard refresh.
Exactly the
If you
point.
think it's just me and Alex, think again. We got a whole bunch of people working with us right now. We're just the only two people on camera.
Good. So it's being loaded.
All right.
Okay.
Is it that good German bandwidth that we're looking at?
Yeah, I have pretty good bandwidth here. I bet it's on the mentee side. Because, well, my connection with YouTube is perfect. You see, I'm streaming and YouTube is absolutely happy of the connection. So,
yep.
Okay, I will try to do it again. Just a second.
I love this part of the show.
Yeah, it's a live show.
Like, yeah, it's live. You know, you do it live. This is what happens. So I'm going to go over to the chat and see what's happening over here real quick.
Yeah, so let us ask quick questions meanwhile. Good. Presentations.
It's always funny whenever these things happen. Everyone asks, is mentee using Cassandra? No. And mentee is funny because I really like it, and we've seen it take thousands and thousands of users, but yeah, sometimes it just has these weird things. They're a startup. We'll go talk to them, but yeah, there's a lot of lag on it. So okay, we may have to we have to move on.
I will try to start it in the next screen, so give me a second. Maybe this one will work. Oh, it looks like this one works. Perfect. So, key spaces, tables, partitions, and a little bit of more, and that's important. Why it's important? So, I will say only a few very tiny words about the infrastructure, but you have to understand how it fits to infrastructure, as we are going to speak a little bit about the key spaces. So, in this bottom of every system, there is a simple server doing his or her job. And it can be a single bare metal server, it can be virtual instance or a Docker container. Well, as long as you use Astra, you don't have to care of that. But if you are running your own cluster, you better understand things like that. Then, data center is a group of nodes. And in theory, they are located on the same physical location or a cloud data center or an availability zone, depending on your setup. And finally, cluster is a group of data centers. Well, it may consist of only one data center, but you definitely need at least one to run some Cassandra things. So it's a group of data centers configured to work together. Okay, but we are speaking about the data model. So let's get closer to data. The smallest unit you can access in general in the table-based databases is a cell. Cell is an intersect of a row and column storing data. When we start to speak of a row is a single structured data item in a table having some properties stored. And at some point you may ask me, Alex, why do you say me these basic things? I know what's the row, I know what's the cell, I even know what's the table is. And well, yes and no, because Cassandra data structure is a bit different. In the relational databases, and you want to access some data, you specify the database, you specify table, and then you can specify a row, and that's all what you think. Like select a username from users, where a last name is something. In Cassandra, it's different because Cassandra is designed to work with any tremendous, huge amounts of data you may imagine, while dispatching the data and storing the data within very milliseconds, and it's being distributed all over the world. If you think it's a simple job, try to do it yourself. So, in the relational databases, when you have too much data to handle on a single machine, you have to go sharding. And some of you, I know, like, it's hard. I did sharding. It's really painful. If you did that, you know how much problem it brings. If you didn't, God bless you. Hope you will never do it in your life. In Cassandra, you don't have to take care of a sharding because there is no sharding. All the data is partitioned in the very beginning. So what's a partition? Partition is a part of a table. Partition is a group of rows united by the similar column having the same value within the same column or columns, and they are stored together. That's very important to understand. If we have people in the table of employees, we have people from different, from the same department, it will be a single partition. I explain it in a few steps later. And they will be stored together. And that's from one point of view, very important positive feature. From another point of view, you really have to be careful at some points. But don't worry, we will make you efficient with Cassandra in some next slides. And finally, table. Well, I bet you're familiar with table. It's a group of columns and rows storing partitions. And then key space is a group of tables having the same replication strategy and replication factor and some other properties we will not cover today because it's more about operations and maintenance. And if we watch it from above, so we have a key space, which is a container for tables. Tables are containers for the partitions. And getting the more close to life example, if we watch the table of users by CT, we see what the CT was a partition key column for this table, and we have some clustering columns and data columns, and I explain them in a minute. But you know what? I believe all of you, or at least most of you, are very technical persons, ladies and gentlemen, so let's get closer to the code. Talk is cheap, show me the code. The code in this case is very simple. Well, if you are trying to work with the database, store some data in the database, you have to create a key space first. Key space which will define your properties for your table stored within this key space. So here in the SQL, which is a Cassandra query language, looks very familiar to SQL, but not the same. I'm defining a key space, call it users, with replication strategy, network topology strategy. It was explained at the last week, so I will not go deeper. And replication factor. So in this example, for the United States West 1 data center, we will have 3 replicas. And for Europe Central 1, so let's say it's Frankfurt next to me, we will also have replication factor 3. Notice what you may have different replication factor for different data centers. And when we speak about creating a table in the SQL, I believe syntax should be very familiar to you because it's almost completely matches the traditional relational SQL queries creating tables, except of the last line, which really important. So we discuss it very thoroughly in the next slide. But still, when we're creating a table, we have to define key space. It will be allocated to table name. Well, it will be hard to access table without knowing table's name. Some fields and type of this field, and then primary key. In our case, as a primary key, we define city, last name, first name, and email, and city will be a partition key. Okay, what does that mean? Primary key, that's important thing. The main duties for the primary key is to ensure uniqueness of the row, and it may define sorting if you want to. Imagine this example without email within the primary key. What would happen? Very simple. City, last name, first name, and every second John Smith in New York will be very unhappy having his data overwritten. So first duty of a primary key is to ensure uniqueness. And what does it consist of? It consists of a partition key, which is absolutely required. You cannot define a table without a partition key. And clustering columns. Clustering columns needed to define uniqueness and sorting order. I explain it in the next slide. Good example, well, not perfect example, but acceptable example of a primary key. City, last name, first name, email. We expect every person have unique email, so we are fine with that. A primary key consisting only of a user ID. Okay, it's also fine. It will be table users, and primary key will be equal to partition key. Okay, works as well. That's fine. What would be a bad example, as I've shown you, city, last name, first name? Some people may be very disappointed. Partition key. Now it's getting more interesting. So we discuss it. What we have to work, we have to be ready to work with any amounts of data, even with very big amounts of data. And what does that mean, big data? There are a lot of different definitions, most of them complex and not really explain anything. My favorite definition for the big data is the data which doesn't fit to a single server. It means what we have to partition, and partition key is the field which will identify the partition value and therefore create token based on that. I show it in a moment. And finally, clustering columns are needed to ensure uniqueness and sorting order. What does that mean? First, uniqueness. It would be a very bad table users by city if my primary key would consist only of a city. It would mean what I may have only one user per city. And when I add last name and first name, it's getting a little bit better, but still bad because, well, I may have more than one John Smith in the city, or whatever most popular name in your country, Ivan, Ivanov, or I don't know. Then the example downstairs, city, last name, first name, email, gets much better. But there is a second duty for clustering columns, which comes very handy sometimes. Primary key, video ID, comment ID. What happens right now? Like, take a look, we have a YouTube or killer video, and there are a lot of comments for every video. If they have the table like that, video ID as a partition key and comment ID as a clustering column, if that comment ID is just normal unique ID, I will have those comments not sorted. Imagine you are opening a YouTube video page. You have all the comments, well, at least like it was before, most recent in the beginning and oldest in the bottom. Good. So when I fetch comments like that, I may have them not sorted. Maybe you remember right path in the first week, everything is pre-sorted, so you don't have to take care of the sorting if your data model is right. Take a look at the last fourth primary key. Video ID, created at, comment ID. I still do need to have comment ID in the clustering columns because to ensure uniqueness, two different comments may be written at the same time, so second will overwrite the first. I don't want it. So I add created at, and I needed to establish the sorting order and to have the latest comments first. And here comes the very important point. How exactly partition happened to be? How we create a partition, or better to say, how Cassandra creates a new partition, or how Cassandra finds a partition to add something or read something from. We are working with this,
hey, Alex, real quick, man. I think you're going to have to get rid of my head because I'm cutting off slides, man.
Oh, no, but no way, and you are cutting them only a little. You know what? I'm a magician. I can make you a little bit smaller if you don't mind.
No, don't shrink.
Yeah, I shrink you, sorry. And that's I will right. Shrink myself.
Yeah, shrink yourself a little bit.
Yeah.
You know, this is as wonderful it is that to see your face. I'm sure the slides are more important.
Yeah. Good. Well, you know, I'm not a top model to take care about my face too much. I can do it in mask. No one cares.
But look, it's a replication factor.
Yeah. Good.
Oh, the other way. A replication factor. There we go.
Yeah.
Yes. Like, oh, okay, now I see it. All right, as you were.
Good. Thank you so much. So we are working with this example, users by city, with city, last name, first name, address, email, and primary key. We discussed it before. Now, that's important to understand. Every node is responsible for the range of those tokens. So let's imagine a very simple example. We have 10 nodes and 100 of tokens. So first nodes will be responsible for tokens from 0 to 9. Second node will be responsible for tokens from 10 to 19, and so on. So all the 100 of tokens will be covered. And, well, obviously those big numbers are much, much bigger, but idea is the same. We have really a lot of tokens, and as much as we have nodes, with replication factor 1, of course, those ranges will be splitted over those nodes. And if you have replication factor 3, every node will be responsible for the 3 ranges out of this list. Now, you're inserting a new row. And you obviously must specify a partition key. It cannot be null. You always must specify the partition key. What happens next? We are hashing this value using murmur-free hasher, and result is the token to use. For example, if we add a user from Seattle, using this hasher, you can get this token, and token will be 24667171130. And therefore, token for this partition will be the number I've just read. I don't want to read it second time again, sorry. So, and therefore, all the users from the same city will have the same partition token, and they will belong to the same partition. So they go to the proper node or nodes, depending on your replication factor. And replica nodes responsible for this range will store this data. And therefore, then you read the data, you must specify the partition key. Well, you can try to avoid that, but we do not recommend that to allow full cluster scan. And well, when it works, I've seen a lot of questions at the last workshop, like how does driver knows which node to ask, or don't, or maybe driver doesn't know which node to ask and ask a random node, and then this random node asks the next random node. And if you have 10,000 nodes, you have to ask every of them? Of course not. Every Cassandra node is very smart, as every Cassandra driver is also very smart. In the beginning, then it starts to work, it loads the data about schema. Where is every partition stored, which node is responsible for which tokens. And then when you do a select in your driver using exactly the same way to calculate the range, to calculate the token, uses this murmur-free hasher to calculate the value and knows which node to ask and goes directly to this node. Oops. Good. Now, you see the label, the slide of the year award. I did it because, well, I do believe what this slide and next few slides that's what the red line, what distracts you, what makes you or successful with Cassandra or not. If you know the rules of a good partitioning, then you will be successful. If you don't, your data model cannot be good, and therefore on every next high load, you will get some real troubles. So let's cover the rules of a good partition. How do you define partition so it will be efficient? Well, we have to cover 3 main rules. First rule is store together what you retrieve together. Don't forget, all the rows within the same partition are stored together, very close to each other, within the same file or within the same block in your memory, on the same node. So when you are trying to load this data and you ask for a single partition and everything is you need in the single partition, then you just get this partition immediately, and it works extremely fast, lightningly fast. But if you have to try to fetch some data from multiple nodes, from multiple different partitions, that's obviously it's going to be not so fast process. If you have like some hundreds of servers, basically you have to ask a lot of them, and that's not the best way. So we try to store together what we retrieve together. In this example, I told you before, if you open a page, a video page at YouTube or killer video, you get the list of comments immediately. In the first example, partition key is video ID, and primary key is video ID, created at, and comment ID. And that's a very good example of the store together what you retrieve together, because in this case, partition will be based off the ID identifier of the video. And therefore,
Alex?
Yeah, sure.
I think this is a good time to insert a question. I saw this in chat. And the question was, how Cassandra makes sure a unique partition, or how does it make sure that we have a unique key value? And you mentioned this, but I want to make sure this is really in everyone's head.
Yep.
Is when you create a partition key, will be hashed using the murmur3 hasher. We used to use MD5, but now we use murmur3. Murmur3 is, and that's just thank you for going back to that slide. It is a consistent hashing algorithm, meaning whatever string you put into it will always that if you put the same string in, you'll always get the same 64-bit number out of it. And so that number, how that's created, that's actually the feature of murmur3, is that it is so randomized, and this is pretty close to like a cryptographic algorithm, but it's not suitable for crypto. But murmur3 will take anything and make it unique, and 64-bit, that bit space is so big that there's no collisions inside of that. Now, sure, in a long enough time there could be a collision, but not in any of our lifetimes, and not before you retire, so don't worry about that. But I want to make sure that that's what's built into Cassandra, that's making sure that whenever the data is placed on the ring inside of the cluster, that it does have a unique space and it's grouped by node.
Yep. Thank you.
All right.
Good. So, and finally, as I open a video page, I get all the comments of this video together, because they will be located in the same partition. As they all belong to the same video, their partitioned token will be the same. They are stored together. Very simple. Now, avoid big partitions. Take a look. Cassandra may look simple for a developer, but inside there is a lot of work. And as your partition are getting bigger and bigger, you may run into a trap. Then your partition is too big, and then compaction cannot handle of your SSTable files, and then some nodes may stuck completely. So take a look. There is a very good example explaining that. You are selling some things in some countries, like in Europe, for example. At some point, you go to China, and you somehow magically become extremely successful in China. And like everyone in China wants to buy something of your goods. Congratulations. But if you have used the partition key like that, with country, now you have a big problem, because our partitions will be fine, but this single partition will be too big, and therefore it will be hard for a Cassandra node tool to take care of the things like that. And then your system administrators or database administrators will be unhappy. They will come, make some noises, and call you bad names, and no one wants it. So watch your partitions, don't let them be too big. Technically, there are no real limitations, like physical limitations, because it's well defined. It depends on your hardware. But in general, we recommend to have like approximately up to 100 key rows in a partition and up to 100 megabytes in a partition. In general, that's about size more than about the rows. And in the first example, we see video ID for comments from a video. This is acceptable because Although some videos may be too big, I mean amounts of comments, but the most popular videos at YouTube at this point have around 5 millions of the comments per video, like Gangnam Style or something like that. 5 million comments is obviously more than 100,000 rows in a partition, but it's acceptable because all of them are small. So usual comment is like video ID, comment ID, created at, user, text. So there is not so much information and they aren't so big. Good. Now, I told you to avoid big partitions, but there can be something different. Take a look at the example. Huge Internet of Things infrastructure, hardware all over the world. Different sensors reporting their state every 10 seconds, and there are really like a lot of them. Every sensor reports its ID, timestamp of the day, like when this happened, and the value. And we speak what sensor ID is a universally unique ID. Timestamp, well, is a timestamp. And value is just a float or maybe integer. In our case, it's not important. And in the beginning, I'm as a developer of the data model for the system decide. I will go with primary key sensor ID reported at, and my partition key will be sensor ID. Because, well, rule number 1, store together what you retrieve together. And, well, in the beginning it works pretty well and everyone is happy. But after some time, I get into trouble. Something is going wrong. Try to think a little bit of what can go wrong using these partitioning. Patrick, how do you think how much time we have to give them?
Well, let's see. We're at 10 minutes before the hour, so we have about another an hour and 10 minutes before the end of our workshop. So, what slide are we at?
We have a lot of slides. So, okay, I hope you got enough time to find out the problem and identify the issue. But if you didn't, well, then watch what's happening on the screen. Let's go. I told you, avoid big partitions, but that's not the whole truth. Avoid big and constantly growing partitions. In the beginning, it was pretty fine, but as every sensor reports its state every 10 seconds, constantly, then the partitions, which were perfectly fine in the beginning, got growing and growing and growing, and boom, and we have cluster paralyzed because all the partitions are too big. So we need something better, but well, using the sensor ID seems to be obviously not the best way to handle it. Is there a good way to solve it? Answer is yes. Answer is bucketing. Bucketing. Bucketing.
Well, that's a big enough word. Did everyone catch that?
Yes.
Bucketing. Well, you should probably explain what bucketing actually is.
Yeah, sure. Bucketing. I hope you got it. So, what's the bucketing means? Our partition key may be not a single column, but a composite column or multiple columns value. So, you may specify in the partition key not only like country, but also a city, and then this composite key will be calculated using this, will be hashed, and therefore value will be different because we are using not only single column value, but two different columns values. And in our case, we may use bucketing, so use composite partition keys to have multiple partitions per sensor. And I again give you like 5-10 seconds, we don't have more, to think what you would think to use out of what we have to do buckets and to separate sensor reports, still having some reasonable good partitions. 5 seconds. 5. Boom. So let's get to the answer. Answer is, one of the typical approaches for the bucketing is to use some synthetical field which needed only for bucketing, based on the timestamp. If you thought like maybe a timestamp could be a good partition key, well, yes and no, it would solve our problem of two big partitions. But meanwhile, when querying a database, we always have to specify a full partition key, and therefore all the columns of a partition key. You definitely don't want to try to select data from your database, specifying all the possible dates, especially considering inequalities for partition keys are not supported. So what happens in this case? This month year new value, it happens out of timestamp, and it can be integer or string, that doesn't matter basically. Today, take a look, that's July of year 2012. So month year value will be in this case 072020. And that's absolutely synthetical field. You don't want to use it for anything else except of a bucketing, but it creates great buckets for our data. So it's easy to calculate, and if you need, it's easy to retrieve data, to store data, and if you need to get data for last 3 months, you simply can still get it within the single select statement with specifying explicitly what kind of a partition you need, and we can calculate the partitions with no issues here.
And Alex, I always recommend people use data that you have and not make up new data. So if you have a timestamp in the IoT stream, say like a device gives up its timestamp, like here's the data, use the data inside that timestamp, and that way you don't have to make up anything. There's no calculations that need to be done, and it's also synthetic in a way that whenever you do your query, it matches what you're looking for.
Yep, and that's very easy to use. And then what happens when we have a composite partition key like that? It consists of sensor ID, all the time the same for the same sensor, and month year. So as soon as month is over, and next month will be August, it will be therefore 08 to 020, and then bucket is full, and it will be never written again. So great. And last thing we want to avoid hot partitions, or maybe better to say, avoid uneven distribution of data over your partitions. If you see what your partition is the size of, I don't know, 100 megabytes, and 3 other your partitions, imagine you have only 4 partitions, weird situation, but okay, are small, usually it means what the partition is being written or being read all the time, while other partitions are idling. You may say like, okay, it's not so big problem, but well, it is a problem. Why? Let me get back a few slides. All the partitions will be spread over the over the known amounts of nodes in your data center. And when you have one partition is very busy and other partitions are idling, therefore some of your servers amount equal to replication factor, very busy storing and dispatching data, while others are being idling. And obviously, then you imagine you have 100 servers and partitioning done wrong. You may add another 100 of powerful servers. You can add 1,000 of powerful servers. It will not help if your partition is still being dispatched by the same server. That's why I say, that's why I call those slides is Slide of the Year award. Because if you do it wrong, well, you will have it working wrong. And that's why data modeling with Cassandra is so important. So in our example here, we have 3 examples. First example is marked as good for you so easy to see. We have primary key consisting only of a user ID. Every user ID has unique ID, and therefore we will have as much partitions as we have users. And it's perfectly fine. You may have any amounts of partitions. That's not a problem. Second key Video ID is the partition key, and created at and comment ID are clustering columns to ensure uniqueness. Is it good or not? Well, it will work. As I said before, the biggest known amount of comments for a video at YouTube at now around 5 millions. So therefore, and those are small data, it will fit. But if anything goes wrong, or if humanity and infrastructure here develops in some weird manner, so every of your Internet of Things units, like, I don't know, your Alexa or your mobile phone will go to the internet and write their own comments, when immediately, boom, those partitions are too big. So if you have surprisingly big amount of comments, then it's already not so good model. And we may need bucketing, as discussed before. And last example, primary key of country and user ID and partition out of country. That's the bad example. For some countries, you will have hot partitions. And for some countries, like, you know, I live next to Belgium, like pretty small country, for example, or there are some even smaller countries, they obviously will be idling. Good. And the last point again, always specify the partition key. If there is no partition key in a query, which node you will ask, as long as you have cluster of 3 nodes or 5, 6 nodes, it may be not so bad. Well, it's still bad. It's a very bad practice. But if there is no partition, which node you will ask? This, or maybe that? If you don't know a partition key, you don't know which node to ask, and then you ask every node in the key space responsible for data of this key space. As you can guess, that's a very bad pattern, very anti-pattern, and you should avoid that at all costs, at all times. Good. And therefore, that's how this query should be, considering we are working with the same users by city. If you just select address from users by city specifying only first name, we don't know which node to ask. There is a technique allowing you to do the query, but I will not tell you because you better not do it. But you may find it on your own. And we can select address from here, specifying the partition key and any of clustering columns if you want to. Good. Now,
that was a big section.
Yeah.
So we have. Let's take a breath here.
Mm-hmm.
I'm gonna add a little bit to that. Is that you just learned something that's really probably the most important part of Cassandra data modeling is how to create a primary key. Everything else in a data model is just along for the ride. The partition key, the clustering columns, understanding how those work, and they're not going to be intuitive right away because it's not exactly the same as a relational database, but understanding that is really critical. So just want to make sure everyone knows that. And if you're going to do the homework, and again, remember the homework is to get certified. If you want to get certified, do the homework because the homework goes way farther in depth. You will get a lot more out of that. Today's session, yes, the last week's session, gives you a lot of information. And if you're not interested in getting certified, then you don't need to do the homework.
Exactly. Okay, then. I will shrink us again. Good. So, data modeling for Cassandra is different, but you maybe not understand yet how different it is. And as we seen at the mentee in the beginning, what many people have experience with relational databases, we will use them, relational data modeling, as the example. So our next development will be built on some comparison, and it's easier to understand. So, how do you usually work with relational data modeling here? First, you go with the domain of the data, the practical domain you are going to work with. In our case, at this step, we will work with employees in departments. So imagine we are working with a field like for application like enterprise resource management, something, nor something just to handle employees. First, you analyze the domain. You analyze the raw data to identify entities, their relations, and their properties you have to take care of. Then you design table using normal forms and foreign keys. And then you start to use them, and you have to get normalized data from multiple tables. You use join when doing queries to join data from multiple queries. For example, normalize it means what you don't have too much of data duplication. Normalization is the process of structuring relational database, well, up to some normal forms in order to reduce data redundancy and improve integrity. And what does that mean? It means what you repeat no data except explicitly must be repeated. If you have employees and departments, you don't write for an employee in employee table what his or her department is. You write just a name and first name, so pretty unique things. And when you have a special table for departments, and then when you need to retrieve the data with your select department, select first name, last name, department from employees, left join department, blah, blah, blah. You know how it works. And it's good, and that's this approach was the most used one for dozens of years, because, well, it has some serious benefits, some very serious pros. Simple to write, something changes, you write it one time, and using foreign keys and relations, you may maintain data integrity in much simpler manner, because, well, very often it's a job of a database to take care of the data integrity, on delete cascade and all the things like that. And negative sides of a normalization: slow reads and complex queries. So when you need to do some select for a dashboard, and then you are going to load really a lot of data, you may have some real troubles because the query may be tremendously huge and obviously very slow. One time in my life, I ran into a limitation. I've asked our attendees all the time, so now I want to ask Patrick, maybe you have met something like that before. What's the maximum allowed amount of joins in a single select statement in MySQL server of a version? Well, I don't know the version, I don't remember the version, but it was approximately 7 years ago.
The maximum amount of joins you can do?
How much joins you may do in one single select statement in MySQL?
Isn't it 64?
Almost. Oh my God. I see a man of a culture here. Yes.
Come on. Database. I actually wrote a relational database in my life. Come on.
Yeah.
And I know why the number might be 64.
So answer is 61. Yes.
All right. Okay. Right. And I think I know why too. All right. So sure.
Good.
You need 3 digits off of that. It's pretty close.
Yeah. But seriously, guys, girls, can you imagine?
We got people answering the question in chat. 61. All right. So if you're doing a select with 61 joins in there, stop.
Yeah, seriously. I mean, can you imagine this query? It's nearly impossible to analyze. A slow query tool gets like that, seeing that. Obviously, it works very slow, and well, it's not the.
Well, it's a data warehouse query. Let's be fair. That would be a data warehouse query if you're doing something like that. You're not putting that on your website, and if you are.
Well, there are different situations, but in general, yes, avoid it at all costs. Okay, so we discussed the normalization, and we agreed what very often when you want your reads to be very fast, you cannot afford normalization. So if we can afford a normalization, then what do? We go with denormalization. Denormalization is the exactly opposite strategy when you duplicate data storage in your data to increase the performance, especially read performance. Some people argue what like Cassandra is read optimized, Cassandra is write optimized, and when people read about the denormalization and say, oh, Cassandra is read optimized, well, that's not about that. That's the same approach you can use with every database, including like your PostgreSQL or Oracle or whatever you're using. It still works the same way. You duplicate your data, you can read it faster, you can do a single select instead of 61 joins. But with some price. Everything comes with some costs. What's the benefits of a denormalization? Very simple. Quick read. You have everything, as on the example on the right side, you have a department name within the employees table, and therefore, when you want to read something about your engineer, then you just read this data and you are done. One single statement. Simple queries, really easy to analyze. There is no need to use a slow query thing, mostly, well, because everything is simple and you can read and understand it easily. Negative sides, you obviously need some multiple writes when you are updating data. And now you have to take care of the integrity, as a database cannot help you here anymore. Developers have more work to do. But you know what? As a developer, I'm mostly fine with that because it means higher salary. Now, NoSQL data modeling. It goes exactly opposite way. We don't think about the data, then model, then application. But we think of the application to model to data, or I would better say not application, but users, people, customers. Like stop thinking of the cold hardware, think of the people instead. It's much better. And we think what our guests, attendees, users, customers, clients wants to have, what their behavior and what the results they want to get, and what's the data they want to store. And based on that, we are identifying workflows of the application, dependencies of these workflows, and needs of these workflows. Based on the workflows, we can design queries to fulfill these workflows, how exactly we are going to reach the database. And knowing the queries, we design tables using denormalization. And when to handle the problems of multiple writes, we use batches when inserting or updating denormalized data to multiple tables. And you may want to ask me what's the batch it is, and I will tell you, Cedric will tell you what's the batch it is next week. Every next week we have something very special to you, so stay tuned and visit the next workshop as well. But enough words. Talk is cheap. Show me the code. Let's go practical. Let's work with real examples, so you will see how it happened in the real life. In our case, we are going to work with a killer video. Killervideo.com is our reference application. We show how we work with Cassandra and DataStax Enterprise. And therefore, as it's a killer video, you may guess by name, it's a YouTube killer site we developed to then overcome YouTube at some point in the time. Just kidding. So, first thing we are going to do, we are going to add comments and new feature to add comments to the videos. And designing process step by step says our first thing to do is to identify entities and their relationships. Just call it all together conceptual data model, because, well, entities are still the same. You do relational or no relational. And then we must identify application workflows, which leads us to know our queries. And knowing query is everything. When we speak about the conceptual data model, and we think of the comments, conceptual data model is pretty simple. We have basically three entities here: user, video, and comment. And every user having ID, email, every video has ID, title, description, and every comment has author, has a target video, timestamp when it happened, and the comment text by itself. Every user can write multiple comments to a video, but every comment may have only one single owner. And basically that's our conceptual data model for this case. It's very simple. I bet you've seen something like that, much harder than that, many times already. Then we start to think of the application workflow. To simplify this example, I will cover only 3 use cases. And use case 1, a user opens a video page. As shown before, we open a video page, we watch the video, we want to see the comments. Well, comments at YouTube usually don't deserve to read them. Sorry, at Killer Video it's much easier because there are not so many comments so far. But anyway, how do we load comments when a user opens a video page? Use case 1. Answer is simple. We need to find all comments related to the target video, given the no video ID, because user has opened this video already, and we have to show most recent first. That should be a pretty simple use case. I don't want to get too deep into that. Open the video, watch the comments. Simple. Use cases are number 2 and 3 are very similar. They for different purposes, but they're matching. When user opens his own or her own profile, he or she may want to see what's the recent comments and the rating of those comments, like maybe someone was excited or not so excited out of his comment. And second case, when a user has been reported for spamming and the moderator wants to verify a user if it's user a spammer or not, easiest way for a moderator just to open all the comments of this user, sorted by time, and see the latest to see if he's or she's writing spam or not. Maybe should be blocked. So workflow 2 then sounds: find comments related to target user using its identifier get most recent first. Well, this one also should be pretty clear. Comments related to user given we know user ID. If you want to see user ID, you need to know the identifier of this user. Pretty simple. When we map this knowledge all together and we start to think of the queries and how do we want to execute them, we need to find comments posted by a user with a known ID, and we need to find comments for a video with a known ID. And that's how our query may look like. Normally, we don't recommend to use asterisk in the beginning, wildcard in the beginning, select wildcard. In general, bad idea, but to simplify it may work well. Now, I want you to think, stop listening, and think a little bit. Why do we think of having 2 different tables in this case? Why do we think of having already table comments by user and comments by video? There is a very solid reason for that. So, answer is partitions. Partition keys, you need to know it when you are selecting something. If you need to load comments by user, you cannot execute query to comments by video because only video ID is known, and vice versa. So when we getting to logical data model, comments by user table looks pretty simple to us. User ID is going to be partition key, when creation date and comment ID as the clustering columns to ensure sorting, so we don't have to sort manually anything, and comment ID just for uniqueness. And video ID and comment will be data columns, just storing data. And comments by video, video ID as partition key and creation date as clustering column, the same as for comments by user. Tables look very similar, but they cannot be executed, they cannot replace each other. We need to have 2 tables here to load data quick and load data having any amount of data we have, we're still able to dispatch those comments within milliseconds. Then, interesting trick comes, one of the tricks I really like, Cassandra. You remember we just had 5 fields per table, and boom, we have already 4. Why? Magic comes, we have a great type called time UUID. As normal UUID is the universally unique ID, very long line of different characters and numbers, digits. it's good, but comment ID is something even better. It's like a universally unique ID, but with a timestamp integrated directly into that. So it looks like UUID, it behaves like UUID, but also you can sort by UUID, and it will be sorted based on the time you built into that, and you can extract time if you need that. So the fields creation date and comment ID are merged to have one single time UUID, and our table's already smaller, and that's great. And finally, based on all the things we discussed before, we can create table, if not exist, comments by user with user ID, UUID, comment ID, time UUID, identifier of the video and comment, just text, with primary key, user ID, and comment ID, you see only one here, and with clustering or order by comment ID. And basically it goes the same for comments by video, but in a little bit different order. So we are having primary key, video ID, not user ID. And
all right, moving on.
Yeah, we have the latest and the shortest part of the workshop. The most important things are covered. Now we have very briefly to speak about the data types. So, list of the basic data types is pretty big, but there is simple in general because it's exactly the things you are used to have in any other database. You are using all the integers, strings, and all these kind of things like that. The only interesting approach is the time UUID, which I've explained to you already, so I don't want to stuck at this step. Collections. Those are a little bit more interesting. Collection are the set, list, and the map. Well, map is pretty simple. Key value, key value, key value. Set is a set of unordered things, and list is the same as set, except of it has an order of the things happening inside. Working with set, we can think of simple things like tags. Then you set a tag to a video when you usually don't care so much of the order, and there are no things like ordering tags. So set is a very simple approach to store text like tags and keeping them together within one field. Things you can do with the collection type set is pretty obvious. You can insert things including sets. You can update set and you can replace the whole set in general, or you can add something to set with just a normal plus option to add something to the existing text, as you see down here. And important, set doesn't care of your order. List looks similar, but it cares of the order you are inserting data into that. So you still can insert. You also can replace the entire list, wrapping it out completely, and you can append list to add some more, and therefore it will be the last in the list. Additionally, you may replace an element and change one element of the list to another one. Map. Well, these things should be familiar to everyone working in the software development. Key value, key value. Like in this case, we can have collection of type of phone numbers, like every person, every user may have multiple phone numbers, like work one, home one, mobile one, whatever you can imagine one, and we go with phone numbers. So what we can do? Very easily, we can insert a new one, we can replace entire map, we can add to map, we can change existing key value, like everything what you can do with key value. User-defined types. Those are really great because you can define your own type in Cassandra and work with it like with a native type. So you can simply create a type, killer video address. Notice the key space name. All the user-defined types or UDTs are explicitly assigned to the key spaces, to a key space you created in. And if you want to use the same type with multiple key spaces, therefore you have to create it multiple times, specifying different key spaces you may want it to use. And then within the UDT, you may define different types like texts, integers, whatever you may need. And after the creation of the type, you may use this type within the key space you created it in. So for killer video users, we can define location type address. And that's great because you don't need to have all the additional fields for that. And user-defined types are very used by Cassandra developers. What you can do with user-defined types? You can insert, you can replace the whole UDT, you can replace a simple UDT field, and notice the last page, update killer video users set location city equals. So you do not have to specify the whole UDT, you can access one specific field of the UDT, which is pretty great. And also, moreover, you can require to read one specific field of the UDT, like select location.city from killer video users. And given location is in this case is a type of an address or whatever type you create. Counters. Counter is a very special type. So counter is 64-bit signed integer that you can very quickly work with impressive values such as likes, views, and these kinds of information. Notice, there are a lot of banks using Cassandra, and you definitely want your bank to use counters to operate with your salary or account statement or things like that, because, well, it's not going to look very nice. Counters are not for that. Counters are for quick, imprecise operations, adding likes, adding views, and so on. They support only two operations, increment and decrement. First operation assumes the value is 0, and you cannot set counter to be of the exact value. It only accepts increments or decrements. So, and it cannot be a part of a primary key. It cannot be mixed with other types in the table. Rows with counters cannot be inserted. And updates are not idempotent. That's important to understand. Counters should not be used for precise values. That's important. So how to use that? Very simple table, killer video playback stats. There we have only two fields, two rows, video ID as unique ID, and the partition key and primary key in the end, and views as a counter. And having these killer videos, you can set views. You can increase them and decrease them, specifying an integer value you are adding or removing. Good. So it was a really quick jump into the data types. And you will cover them much deeper and work with them in person on your own at the homework. But when I say on your own, that doesn't mean exactly alone, because you are not alone. You have community.datastacks.com to work with and to ask your questions. You have Discord server to talk all of the things about those exercises with the developer advocates of the team. And we did a great job today.
Woo! All right. So yeah, that was a lot quicker at the end there. So everyone should have an Astra account if you have not gone through the process. So last week we went through the process of creating your own Astra account, and Astra gives you Cassandra as a service. This is as a free tier, free for life. There's no time limit on it, and there's a limit of 10 gigabytes of data, which is actually pretty generous for a free tier, but it gives you enough Cassandra that you can connect to it using your own code or with a notebook. But it's a great place to try out Cassandra without having to go through the process of installing it or getting someone to set it up for you. You can just click a button and you have ready to go. You're ready to rock. So if you haven't done that, go do that now. That's free for you. to do the notebook homework and to do the workshops or the work that's done in Academy, you'll need that. So again, free for life. So once you have it, it's yours forever. What I would really like to see is, at this point is, I mean, who's ready to go build an application? Who's ready to do this? Because I saw a lot of people out there ready to do it. So, I mean, if you're out there right now talking, I see a lot of people in chats, both in Discord and on YouTube, but are you going to go build something really cool? I want to hear from you right now. I mean, yeah? You're ready. I got some readies out there, so cool. And plus ones, me. Awesome. I love to see that kind of energy. We want to hear from you. We have, there's a couple of things I want to point out. If you want to do, I posted a DataStax example in Discord, but we are looking for people to build example code that we can promote and put up on, we do a weekly newsletter or bi-weekly newsletter. We would love to promote what you're doing. So if you're doing something really cool, we want to see it. And if you want to do a talk, join us at one of these workshops. We would love to know about that too. Contact myself, contact Jack, any of the developer advocates. Anyone that's out there that you think is part of DataStax, actually, let them know you want to be a part of this. We need good community voices. Another thing to point out is we also have our Accelerate series, which is happening soon. And those are a lot more fun, but it gives you some stuff like what's happening in the future. Another thing that's happening is ApacheCon, and ApacheCon is going to be virtual. If you're using Cassandra now, we would love to have the, there's a CFP open right now. It will be for the next 4 days. I'm going through all of my community stuff. And then finally, get ready for Cassandra 4.0. Looks like we're going to be shipping a beta here pretty shortly. And I'm really excited about 4.0 because it will be the most stable database on the planet. It's taken years for it to come around, but for good reason. There's going to be a blog post on the Apache website describing all of the testing that has been done on Cassandra 4.0. There's some big users that have been testing full workloads in Cassandra 4.0. This will be a .0 you can actually put into production. And I'm not kidding. Never had that happen before. Have you, Alex?
No, never. Actually, my golden rule of thumb was always wait till first major patch. In normal conditions, I would wait for 4.1. But you know what? I know a team working at the Cassandra 4.0, and I really trust these guys.
Yeah, and it's starting this whole new version of what we're going to be doing with Cassandra in the future. If you're working with Kubernetes, Cassandra is going to be better built for that. It's no longer using JDK 8. It's using JDK 11. Thank you. I saw that in the chat. We have a really interesting blog post on the DataStax website about our testing with some of the new garbage collection techniques around JDK 14, Shenandoah, ZGC. Very interesting, worth looking at. But come on, let's get down to it. You're probably going to use Astra because you don't want to run your own Cassandra, right? So why not? Yeah, and what's happening in Cassandra 5.0, which is after, we're talking about after 4.0, we want you to be involved in that too. So get in the conversation.
Great. Okay, then, a few last things left. Homework. Last years I live in Germany, so I would call it Hausaufgabe. What do you do? First, we have to do notebooks for this course. It will be data modeling and advanced data types. 2 notebooks, and they are stored at github.com, DataStax Academy, Cassandra Workshop Series, week 2. So go get them, do them using your Astra instance, but restart should help. Yes, so we should be back online. Okay,
all
very
right.
well.
Sorry about that, everyone. We're back.
Yeah, exactly. So we are back, and therefore I want to proceed with the slides. So homework. Week 2, notebooks, data modeling, and advanced data types. They are on our GitHub. When there is the academy.datastacks.com, where you have course DS 220. And there are exercises you will do during the first step of homework. So all you need is videos only. And then you have to fill the form validating your presence. And I will try to switch back in a moment. Yes, something is very wrong with my hardware, but I will try to do...
Home stretch, we're almost there, Alex. You can make it.
Yeah. It just happened at the very last second. Incredible. Well, at least not in the beginning. So Google Chrome, yes, that's it.
Well, while Alex is banging on his computer with a hammer, I mean, that's it. We're pretty much at the end of this, but you can see on your screen what you need to do. You should also have an email with everything you need to do. If you have any questions, we never leave Twitch or we never leave Discord. We're also on ASF Slack, most of us. So we're out here. If you have questions, we would love to get your questions on community.datastacks.com, because that's where you can, when you ask a question, you're actually sharing with the rest of the community, because everyone can look at what your question was and they can see the answer. It helps us with like Google search if someone has a similar problem. So really, putting questions on a community is you being a part of our community. Thank you.
Yep.
So next week, we're going to be getting in more into application writing, and that's pretty exciting. And I don't know what else we have to talk about, Alex. I think we can let everyone go.
Yes, we have only 2 more points. This week we have a bonus for you. So if you want to have more and DS22 and notebooks are not enough, you can get deeper and go to katacoda.com/datastacks/courses/Cassandra intro. The links should be available at our main page at the community.datastacks.com. And there are single row partition exercises, multi-row partition exercises, and advanced data types for you to make it to make you learn it better and deeper.
Yep, absolutely.
And let me check if we have anything else. I guess we don't. Last few words about the resources. So what you need to know if you will need that. We have academy.datastacks.com for you to watch the courses. It's a part of your homework of week 1 and week 2, so you have to be there already. To communicate and ask and share ideas and ask questions. There is a community.datastacks.com. Connect with us, follow us at YouTube, Twitter, Twitch, and well, whatever you prefer, we are here so you can reach us. And materials for this week are published already to be at the github.com DataStacks Academy Cassandra Workshop Series Week 2.
And all the links are going into the chats, the YouTube chat, and also on Discord. Feel free to ask. There's plenty of links to go around, but yeah.
Yep, and so week 1 and week 2 of these Cloud Native Cassandra Applications Workshop Series are done. Next week will be Application Development with Cassandra Part 1, and please notice, workshop at Wednesday and Thursday are exactly the same. Both are live, maybe with different speakers, but the content is the same. And the best fits for your time zone, because we want to cover all the world with those workshops. So choose the one which fits better for you. And we are getting closer to part 2 with testing, deploying, and monitoring your applications. Thank you so much for being with us. We are really excited to see you learning with us, and that's really great to have you here.
Great. Thanks, everyone. We'll see you in the next one next week. Have a great week.
Thank you.